Hello, everybody. My name is Christopher. I'm working as a software engineer test in Zurich, and today I'm going to talk about the value of small tests. So just to give you a little bit of background about who am I. I was living in Austria for around 30 years. That's in the small European country to the right. Working in Switzerland since 1 year. Talking today here in Seattle and enjoying a drink afterward. And if you ever want to have a good vacation, just go to New Zealand over there. I can definitely recommend it. We had a bunch of presentations here which were really good, and which were really good in terms of pictures, the message, and so on. I want to make it more interactive. So instead of boring you with, this kind of charts and bullet point lists and so on, I want to have this like a more interactive presentation to entertain you while you're waiting for lunchtime. So in general, when you have any concerns or any questions on what I'm saying here, just raise your hand, clap your hand, throw something at me, just shout. Let's have a conversation somehow. Okay, let's start. So the first question is, just for me, out of curiosity, how many of you are actually seeing the code of developers? So how many of you, wow, that's more than expected, okay. How many of you are satisfied with the code quality of the developers? Okay, that's half. That's good. So do you think that developers are doing a good job on testing the code? 1, 2, 3, 10, 15? Okay. So to give a little bit of background why I'm asking these questions. So I switched to the test engineering world around 8 years ago. And I had, in the beginning, I had to automate the tests for the developer's code. Like I had to make the Selenium tests, or it was this Mercury stuff at this time. And what always drove me is that I found problems while automating, which costed me a day or two, which would have been prevented in an easy way by the developers. Like, returning null instead of the object and so on. Stuff like this. So I changed my mission in terms of educating developers on how to do a better job on the unit test level so that we can focus on our job on automation in much a better way. In the whole presentation, I will use a small example application, which is like, not complex, has some front end, web, MFC, whatever, has some back end and a database, right? It doesn't get into much more detail like this, so we keep this highly high level, and I guess whatever application you're automating, you can fit it somehow into this pattern, hopefully. So what kind of developers did I encounter in the last 8 years? And this is the kind of developer actually I was before I became a test engineer. A lot of self-confidence, right? I write code, I submit it, it might compile. I just trust it will compile, mainly. And that's it. I go home, and the software will work. Nothing more. How many of you saw this type of developer?
Everybody lies.
So those developers are, from my point of view, hard to educate, but we will get back to this one. However, the most common kind of developer I encountered are those people who develop code and who actually are not really sure if they're doing the right thing, right? So they develop something, it compiles. They might add a unit test, they might not add a unit test. But then they have to ship something to the test department, and they say, well, let's see if it works, and tries it out once, like address book application, search for my own name, and if it crashes, well, okay, there is something wrong, I will take a look. So those are the kind of developers, I guess, who saw this kind of developers? Well, less than the first one. Frustrating. So those kind of developers care about quality. Like they want to deliver something good. They want to get rid of the work afterward, like debugging and so on. But they don't know how. So suddenly management comes in and says, we need a test department. So then the test department comes in. By coincidence, I'm having the same tester guy as the model-based testing, or his twin brother. So the test department says, okay, but before you put something into production, give it us first. We want to take a look, some staging instance, canarying, whatever. So the developer says, yeah, that's good. Somebody will check it before it goes to production. I'm fine. And sets up this test environment, like copy of the database, or copy of the server or both of them, right? Or the same database if it's read-only, hopefully only if it's read-only. So then the tester tries to test. And this is where it all started, because suddenly the testers tried to test an application which is a completely black box from their point of view. So they saw the web front end. They knew the database is maybe a test database, but they didn't have any access, or maybe they got access after half a year, after they got a trusted relationship and so on. And they tried to test all this functionality between web front and server implementation and so on via the test scripts. So they made some scripts in WinRunner, Selenium WebDriver, and so on to catch all the problems. So that's better than nothing, right? The problem was that if you go to this direction, first of all, the tests are slow. As we heard yesterday by Marcus and John, it's not the best way to do it because isolation and so on. Secondly, even worse is when you find a problem, and the tester finds a problem, he has to talk to the developer and say, look, I found a problem in your code. And then the developer, first of all, says no, of course. It's a feature, it's not a problem, you made it the wrong way. But then if he goes in and says, yeah, that's right, it's a problem, he takes a long time to find the source of the problem, because he might have some log output, he might try to run it locally, which takes like ages. So there's an easy turnaround time of a day or two to fix a single problem, which is frustrating for the web developers, for the developers as well as for the testers, right? The relationship is not really the best one. Advanced testers at some time decide that testing through the web front end is not the best idea. Or it's a good idea in terms of end-to-end testing, but not the best idea in terms of testing the backend. So they fired the test scripts directly against the server implementation. And then, so this was at the company I was working around 5 years ago. And then suddenly the developers approached us and said, hey, you know, you're doing all the scripts, and that's really fantastic, but I want to execute the tests as well. I want to have some confidence that my stuff is doing a good work, right? So they heard the term unit test somewhere and wanted to do it. So they asked us, being testers, how to do it. And we made the #1 error. We said, do it the same way we are doing it, which meant you establish a state, you talk to some database, you create some records in the database, you execute your function you want to test, like get persons, get contacts, execute transaction, whatever, and then afterward verify the state of the test. This was the biggest mistake we could do at this time from my point of view, because the result was that the developers thought, that's hard. Writing unit tests is such a lot of work. I have this 30 lines doing the setup work. I have this one line I want to test, right? And then I have another 10 lines of assertions on the state of the system. So why do I do this? And what's the added benefit? Because at the end, the testers have the script running anyway. It's the same thing. Why do I do this? Okay. So this is a fictional conversation. There are no real persons involved in this and so on. So this is what happened to me at some time. Suddenly, a developer approached me and said, could I do more? And then I said, so in reality, I said, yes. Let me answer tomorrow. And then I went back and asked some experts and so on. But at the end, I said to them, yeah, yeah, sure. You could test for stuff which is really hard for us to grab from the script driver front end, right? You could just test for error conditions, for instance. And the developer said, wow, that's great. How can I do it? And I said, yeah, let me just go back and find out. And OK, here's how to do it. And I told them basic things, from my point of view, basic things. But it was just important for them to hear them from somebody which they acknowledged as an expert in the testing domain. So who knows what dependency injection is? Thank you. Who thinks the developers know what dependency injection is? Well, it's almost the same. So it changed in the last 5 years, obviously. So I explained them, you have to make dependency injection. And even though they said, yeah, we know what dependency injection is, I said, OK, hold on a minute. I will just explain you my point of view. You might have the same point of view, then we are aligned. If we're not aligned, take a look. So I explained to him, for instance, in his case, there was this backend application which was talking to the database connection, which was encapsulated in the backend application, and which was managing the connection to some testing instance or production instance of the database, usually production, of course. And I told him, look, if you want to control your program being tested. Like if you want to test your contact manager, you need to have a database which is under your test control. You need a sort of virtual database, right? So this was the code, a little bit more functionality in the real world, right? But this was the code he was taking a look at. He was having a private final member for a database connection. He was initializing the class with the host name, and then setting the connection to the host name. Hard-coded port, hard-coded table name, of course, because it's easier, right? And then I told him, look, you need to do dependency injection. So the first thing he did was that he made a special host name, test123, and had some special logic in the database connection class, which worked, but which was like hard to understand. And the second developer took a look at it, didn't know why it's called test database. So it made the test database 2, the test failed, nobody knew why, and so on and so on. I mean, this example, of course, is pretty obvious to you, right? But it's really important from my point of view to show this kind of simple examples to developers. So basically, I just want to give you the examples you show to your guys afterward, right? Spread the word. So in this specific case, I said to them, look, you need to abstract the implementation from the plan. Like, you need to have something like a database, right? But I don't care if it's a real database, if it's a mock database, if it's a MySQL database, a SQL Server database, or whatever. You just talk about the database interface and what you want to have from the interface, nothing more. Everybody agreeing so far? Everybody hungry? Okay. And then I told him, look, and the next thing you need to achieve your goal is mocking. What I forgot to mention earlier is I never told them that you need to do dependency injection, you need to do mocking. I told them if you want to achieve the goal, like fault injection or whatever, these are the tools you will need to do this. That's a very different message. I don't tell them, you have to do this fancy stuff and so on. I tell them, look, you might want to achieve this, and this is my proposal how you can achieve it. Totally different story, right? How many of you know what a fake is, or what a mock is, or both? Great. How many of you developers know? Okay. Did you have to so did the developers come up with this idea, or did you have to explain to the developers? How many did you have to explain? How many got told by developers? Okay. And for those who had to explain, was it easy? Yes, no, yes? No? Okay. Some hands. So in general, if you want to educate people on mocks and fakes, what I tell them usually is that a mock is a different approach in testing. Like in the mind, the developers were still caught in the state-based testing, right? They saw what we are doing with the test scripts. And they thought, yeah, we are doing the same now. We are making a state, and so on. But a mock is fundamentally different. You test the interaction. You test what your piece of code, the contact manager, is really, really doing, and nothing more and nothing less. Which makes it easy to test for error conditions, right? And an important thing is, for the first time, when you want to show this to developers, sit down with them. Spend half an hour, 1 hour to go through a code example, to go through their code example, right? Or maybe show the contact manager, but maybe with their code examples, spend this half a day to get used to the code and show them how to do it. It will pay off, really. So in this concrete example, I mean, you know this, setting expectations on the mocks, like what do you want the code to do, executing the code being tested, and then verify the API output if you need. And then, I mean, in case of Java, you can use these examples. In case of C++, the examples from yesterday from Lightning Talk. In case of Python, there's something out there. In case of Perl, I have no idea. So the important thing is to explain the change between the expectation phase and the execution phase. Right? They do not establish a state, but you just configure what you expect to be done. As an example, I expect the connection.fetchPerson method with these parameters being called once, and it should throw an exception, which is exactly this kind of fault injection I'm talking about. Could be a SQL exception, could be a connection exception, could be it's Sunday exception, whatever. And then just execute the code, and you're done, right? Usually when I mean, you know this, I know, but usually when I show this to developers, it's an eye-opener sometimes, because they think about mocks in a totally different way. That's my perception, at least. Like 80% of the people think about a mock like something which they can pass in state, it will still compile, it will do something. But it's not this change in mind of setting expectations and verifying the interaction. That's something new for many people. Easy to enhance, right? So in this case, we'll once throw an exception, and the second time return something. Taking the router example of yesterday, which should try 2 times with a 5-minute interval. On the first 2 times, throw some exception, return 0, return false, whatever. On third time, success. You can control the router from both sides. You have it in your control. The reason why I'm saying this is if you give developers an idea that unit testing is not a pain, it's not like this state and doing something and state again. But if you give them an idea that it's something where they can really control what they're doing, like this code is appealing to many developers, and then they just do it, right? They suddenly say, oh yeah, testing is fine. Yeah, I will add another test for this scenario just to be sure. And they get addicted, and the quality will improve. So what happened at the company 5 years ago was suddenly developers spread the word automatically. I went out for vacation, and afterward I got those messages, like somebody said, oh, the tests are so small and fast now. I can run them all the time. And they made their own plugins to run them in Eclipse continuously, for instance, right? They just got the spirit and improved the quality on their own. Or the second one said, yeah, you know, I'm having this library here, the contract manager. It depends on the database connection, but the database connection is done by the guy who went on vacation for 2 weeks and only works on Fridays and Saturdays, and he's always 95% done, so I'm kind of blocked. But now, by mocking out the interface, I could develop my component, and I'm no longer on the critical path. So suddenly, the blame goes to the real people, right? Or told me that suddenly they had less problems in production. They had a lot of crashes in production due to failing database connection, and suddenly the program crashed because it expected the connection to be still alive and so on. And now they could reproduce the problems at least. I mean, it's also about reproducing the problem. Reproducing what happens in your code if the network cable gets plugged. You can't do this as a developer normally, but here they could suddenly. And they really appreciated this and added tests for this. Oh, yeah. And there was this one guy approaching me and saying, you know, I mocked out the word. And I, what? And, yeah, you know, I mocked out the time. We have this yearly letter going out, and I could suddenly test it without changing my local system time. I said, yes, he got it. It was weird, because I usually got mails from him from January 2nd of 2005, because he tested all the time. So that improved at that time. And there was this guy approaching the team, like joining the team, the new guy on the block, who said, yeah, and then I read the tests with all these expects and asserts and whatever, and I understood what it's doing. I understood what the production code is doing. I see some nodding faces here, so this is quite obvious stuff, right? But still it's an eye-opener for many people. I mean, also we at Google, we have people joining in, and we tell them all this stuff in the first 2 weeks. And they say, wow, we can really do that? Yes, you can, with your keyboard even. Okay, the fault stuff already, like if I isolate my test, then I can be sure that whenever it breaks, it's my fault only. Yes, sorry.
You mentioned the case of mocking the time.
Yes.
And time and the file system
yes.
and the network are normally treated by, at least the applications I've worked on, as basic system functionality.
Yes.
It seems to me like that if you put the hooks into your code to mock out all of the potential interfaces of your application, you're going to be really complicating your code base. Do you agree? And if so, do you think it's worth it for the increased testability?
I guess the usual flexible answer is it depends. But yeah, so the real answer is I agree partly. So there are many functionalities which are using, like for if I use the time for writing a log statement, it might be an overkill to verify that it's writing the right time, right? I could just execute the test and verify the log statement is within plus minus 10 seconds, whatever. Or 10 seconds plus looping and so on. If you have some time-dependent functionality, like the router example of yesterday, it definitely makes sense to inject it, right? Because you want to test this behavior. That's my key takeaway. It's this. So my perception is, when I was a developer in the last millennium, I was also having a lot of static dependencies, like for time, for the database connection, the JDBC stuff. That's a miracle by itself. And I had no tests for my code, of course. Yeah, it worked. I'm self-confident. So I shipped it to the testers, and they gave me back, yeah, it doesn't work. And I said, it does work. No, it doesn't work. Yeah, you're right. So I tried to reproduce the problems, right? And now I'm on the other side. I'm doing TDD for all the code I'm writing, which implies that you have a lot of verbose interfaces, like 8 parameters on some constructors, like the time, the temperature, whatever. But it's beneficial for me. I perceive it as beneficial, personally. But in general, I would say just give the options to the developers. And some of them will use it, and some of them will say, nah, I don't do that. Just educate them and give them the option that they are intelligent enough to pick the stuff they really need. That's my message. Talking about the testability stuff of yesterday and the lightning talks, you know, if people have to write their own tests, I mean, you all experience this. If they have to write their own tests, they suddenly clean up the code, right? Suddenly the API is somehow testable. Somehow they have unique IDs on the web interface, or somehow there's not a hidden magic making some credit card billings while you're testing. It just makes it obvious. So by giving the tools to the people, like JUnit, like mocking and so on, they will implicitly change their code to be better testable. Stretch goal, applied test-driven development. If you see somebody making TDD, you know you did it the right way. OK, any questions so far?
Is there any side effects of that process?
There are side effects. We will come to them in about 2 slides. So I will come to it. So when developers write more and more tests and write better tests, this also means that the code is getting better, hopefully. And this also means that your tests might catch less bugs, but you still need to provide them some sort of infrastructure to maintain the tests, to be more aware of what they are doing. It does not mean that you have to provide the infrastructure, but at least provide them the information that such an infrastructure would be beneficial, which includes stuff, basic stuff, like a continuous build. How many of the development teams have a continuous build? Executing all the tests. Half of them, OK. How many developer teams know the coverage data? OK, that's roughly 1/3. So do you know how much coverage your web automation tests provide, your Selenium tests? How many? OK, 5, 6? 2 Googlers? That doesn't count. So it's similar to the dashboard stuff that was talked about yesterday morning. If you just provide the numbers and the content to the developers, they will change something. Not all of them, right? I mean, if you have a team of 10 developers, there will be 2 of them who say, I write perfect code, that's fine, I will go home now. And there are 8 of them who care, who say, yeah, let's see. OK, we don't have any coverage for this module. Well, I have to touch it anyway. I will add some tests. You have those people in the team. You just need to enable them, right? Talking about side effects, yeah. This is one of the texts which I really love most about America. When I watched yesterday evening television, and there's this advertisement for medical stuff, and they say with this dark voice that this information advice published or made available, blah, blah, blah. So yes, mocking and small tests is a good idea, but it's not everything, right? Because developers might, yeah? Sorry? OK. Because developers might take it to the extreme. Like one case, which I guess you know, there's Sylvia doing her component. There's Ashley doing her component and so on. And they just say, yeah, I mock out the whole world around me, it's fine. And then they throw the components together in the subversion system or whatever. It gets compiled, it gets shipped to testing, and the tester says, well, but it compiles, but nothing more. Something is broken, right? And then she says, yeah, but my stuff is working fine, right? And she says, yeah, my stuff is working fine as well. It must be the tester's fault. This is a big danger when you enable people to make small tests, test the components, and so on. And you will see this happening, I'm pretty sure. Or who saw this happening already? Okay, the others will. So the way you can prevent this, from my point of view, is just like similar to the talk with Marcus and John yesterday, who said you have this huge web test, and you have this small test, and you have this medium test in between. It's the same thing, right? But for the other side, you have the small test, but you always need the medium test. And it doesn't replace the Selenium test. It just makes them easier. The key message is that still they should do the component test, because they can test all kinds of functionalities, all kinds of error conditions in their components. And when they integrate, like make the one test where Sylvia has talked to Ashley and so on the other way, they can focus on the integration problems, not on the single problems of the components, right? One of my favorites. What happened to me is I showed them, yeah, you can mock out everything. And then the guy said to me, yeah, but then I had to mock out 17 objects just for one test. What's happening there? So there are two answers to this. The real answer is that's a signal for bad design, right? If you have some functionality which needs to talk to 17 other objects, or 15 if you take away the time and temperature, it's still too much, right? So something is really broken in this functionality. Telling this to developers is one option, but not always working out. So what I usually do to fix this problem on the middle term is to educate them indirectly, like give talks on testable code, give talks on good architecture, and give them the chance to discover, oh yeah, this applies to me as well, right? Give them the chance to discover on their own that they're doing a bad job and they want to improve. And the other trap, of course, is the famous coverage trap. I have one test running everything. Like, I have the Selenium test running all the functionality. Why do I need anything more? Yeah. That's, of course, something you will encounter all the time. Who encountered this? 10? 3 Googlers, doesn't count. Yeah, in this case, usually it comes back to the beginning of the slides, like that you have this isolation of tests and small tests and so on and so on. OK. I didn't find any better clipboard for cheerleading. It's incredible. They're all strange. So, key message. Educate your developers, and it will make your life easier, right? And you can educate them in several ways. First of all, show them TechTalks from YouTube. Show them the talk of testability yesterday. They will get an insight. Show them some articles about efficient testing. Subscribe to the testing blog. Print out the testing on toilet episodes. Persuade them with all kinds of information. From my point of view, at least 80% of developers are eager to pick this up and improve their code. If you want to go for a stretch goal, involve them in writing Selenium tests. Make them write the tests, right? Let them write the Selenium test and let them see if it's easy or hard. And then they will quite naturally make it testable, redesign it, and also test the small components on their own. That's it. Questions? Answers? Whatever. Yes, please.
Yeah, where's the best place to look for examples on mocks?
So the question was, where's the best example to look for examples on mocks? So what I'm usually using is, I'm searching on YouTube, actually, because then you find some tech talks by Google and other companies, which are like half an hour. And what you could just do is schedule a meeting at 2:30 p.m. or schedule a brown bag meeting and just show the video to the guys. In terms of further information, there are, of course, some books out there. And the Google testing blog has a lot of information on this. Like recently, there were more and more articles on testability, mocking, the new operator, singletons, and all this stuff. Yes?
I really enjoyed your German blog posts about testing. Are you have any plans to bring this back or more?
Occasionally, yes. So we don't translate anymore because there's like a pure translation service, and we have the same subscribers on both blogs, but we might come up occasionally with region-specific postings. And if you want to post something, just send an email. You are invited to post as well, German, English, or whatever. Yes?
In the past, when I've sort of introduced the idea of mocks,
Mm-hmm.
developers have responded with, that's cheating. I had to spend a lot of time convincing them, no, if you are testing, you're just testing in a much smaller scope, and it's not cheating. Have you run into that, and if so, have you?
I was running into that as well, and my killer argument, which always worked so far, is how to test for faulty behavior, like how to test what happens if the network cable is plugged and so on, right? If you get the answer, I don't care, well, okay, then you've got one of the first developers, the one with self-confidence, right? Then you have to move on to the next room and try it again. But in general, this helped. And the second thing is that there's some resistance for this new type of testing, right? Because you have to write this expect stuff. It's somehow strange, global methods, whatever. So you might have to guide them through the first few tests, but hopefully they will see the benefit once they're through. If not, then go to the next room.
It's a cheating, really.
Pardon?
Is it cheating?
It's not cheating. It's simulating.
I want it to be cheating.
It's simulating.
You have cheat sheets, right? We have cheat sheets when you go to an exam. It's something like that.
Say it again?
You have cheat sheets. You go to an exam with a cheat sheet.
That's
And
true.
It's
Yeah.
valid.
It's cheat sheets, yes.
Yeah.
But it's not like the hidden code for invisibility in some games, right? It's not that kind of cheating. Yes?
One observation is if you really start drinking the Kool-Aid of dependency injection mocking, you'll realize writing your application in a dynamic language like Python, Ruby, or Perl is a lot more fun than doing it in Java.
Have you tried in C++? That's true. But if you want to appreciate Java, try it in C++, and Java will be fine. I promise. Anything else? Yep.
What do you, maybe if you can give me some ideas of metrics to measure time, like if you just are initiating the idea of doing mocks in your company or with your developers, some ideas to prove some early success to keep the enthusiasm going. You mentioned being a cheerleader and the training stuff, but what can we measure systematically to say, like, this is helping, this is working, this is good?
Okay.
Is this code coverage or are there other things?
So the question is about a metric to measure whether it's good or not in the beginning to motivate the people. This is roughly right.
Not only in the beginning, but also just growing it.
Also growing. Well, I mean, you can come up with some kind of metrics like coverage or whatever. My perception is if people don't feel it like beneficial, they will question the numbers anyway. So even if you say, coverage increased from 40 to 80, it's maybe fine for the management, but developers say, yeah, but it's still we have these problems, and still it's nasty to do this stuff, right? So it might be it differs from person to person, of course. But my perception is that when you talk to somebody and show them the benefits of this, and he gets infected, because suddenly, developers want to write quality code. They want, but they can't really test stuff. They don't have the tools. So you just give them the tools to succeed in the goals they are searching for. Nothing more and nothing less. But the motivation has to come from the developers, right? They want to make sure that the code is working fine in case of a SQL exception. They want to make sure that the code is working fine if the time is going backwards. Okay, bad example, but you get the idea. So you just catch the motivation and give them the tools, and they will carry on automatically. Hopefully. Yes?
Just a comment. Our developers were about 2 years ago bringing the idea of mocking into our company and having a lot of lightning talks and teaching the other developers how to do mocks like we're talking about. And over the course of the last 2 years, we've tended away from that. And at this point, I think we've actually tended to go 180 degrees. A couple of our developers are even now saying, don't use mocks, that we shouldn't tests that had mock objects that were operating as a little eddy. And they would sit there and they would run happily forever and ever and ever while the whole world around them changed and the whole system changed. And the tests were still happy and we didn't get information on the changes that were occurring. And if we had not mocked them up and had them working with real life objects, we would have had a better indicator that these were changing.
So the question was, to summarize, that you had mocking in a company like 2 or 3 years ago, and then the developers went away from mocking because it was too far away from reality, more or less, because the code was fine, the test was fine, but the reality was different. Well, that's this problem, right? That you just have this component here, and Lydia, or Ashley, I think it's Ashley, Ashley thinks that she wants to isolate the whole stuff here, and her code is working fine, but it's nowhere connected to reality. So, I mean, you can solve this partly with medium tests, like Ashley talks to Sarah. But it doesn't replace end-to-end test, right? So it's never, if you only have the small tests, it's not a full coverage. It's full coverage in terms of lines, but not in terms of tests. However, if you have the error conditions here and still the full end-to-end test for the good cases, you should be good to go normally, in my experience. But let's talk about this in detail afterward. I'm curious to learn new stuff here. Anybody else? Yeah.
About creating a pre-submit rules that forces having unit tests and talk to objects. Maybe developers have to do it before they check the code.
Yeah, so the question was about pre-submit rules to have unit tests before they're able to submit. Yes, but again, the developers have to agree, right? So they have, I mean, you have to explain why you need the pre-submit queue, from my point of view. Having the pre-submit queue helps to catch the last 20% who write the perfect code, right? That's for sure. But you have to have the majority of the developers behind you on this concern. Stretch goal, have them write the pre-submit queue, right? That's the best thing that could happen. Anybody else? Everybody hungry? Okay. So enjoy your lunch. See you.
Wait.